session around system demos. This consists of 2 papers. The first paper is Quick Check, a legal research recommendation system. This paper is authored by a group of researchers from Thomson Reuters and will be presented by Don Theo. Don, if you can share your screen.
Okay, hello, can you hear me?
Yeah, we can hear and see.
Okay. Great. Okay, hello, I'm Don Theo, and I'll be presenting our work Quick Check, a legal research recommendation system, and this is on behalf of the Center for AI and Cognitive Computing at Thomson Reuters. So first, a bit of motivation. Litigation attorneys spend a significant amount of time searching for the best authority to support or refute the arguments in a case. And so missing a highly relevant source of law can adversely impact their litigation strategy. Traditional legal research workflows, however, often involve combing through large sets of search engine results or manually exploring a vast network of case citations. And so to aid in this process, a useful legal research assistance system should be able to quickly and accurately find highly relevant missing authority in an attorney's brief, and ideally require minimal user interaction or supervision when doing so. So our system Quick Check was built to address this particular need. The basic workflow is that a user will upload their brief or a memoranda document, either in a completed or draft state, and the recommendation pipeline, which I'll describe, will search for and return a set of case opinions that are most relevant to the legal arguments discussed in the brief. To introduce the recommendation pipeline, it's necessary to first describe the structure of a typical brief document in the US court system. So while the structure of the document can vary by jurisdiction and court level, most briefs have a layout given in the illustration you see here. So the most important section of which is the argument section, which describes in detail the various legal issues that are being raised. And we call each of these subsections an issue segment. And our pipeline considers each issue segment independently and provides case recommendations with respect to a given segment. One of the primary components of our pipeline relies on models that have been trained to differentiate between relevant and irrelevant cases. And so to that end, the relevancy of a case to an issue segment was graded on a 5-point scale by our in-house attorney editors, where a score of 1 is considered an irrelevant case to the segment, and a score of 4 or 5 is a highly relevant case. And in total, we collected a set of over 10,000 graded issue segment to case recommendation pairs for model training. So the recommendation pipeline consists of 3 main components: a document structure extraction component to begin, followed by a candidate case discovery component, and then finally a case ranking component. The entire pipeline can take anywhere from tens of seconds to a couple minutes to complete, depending on the number of issue segments and the length of each segment in the uploaded brief. And so the first step in the pipeline is to extract the issue segments within the brief. And this is done by first converting the original uploaded document into HTML format. The issue segment headers are then identified using a combination of HTML specific cues, such as heading element tags or bold and alignment styles, and the presence of some form of numbering or word capitalization scheme. And after the end of this stage, we have a set of issue segments, each comprising of the header, the constituent paragraphs, and as well the extracted citations from within those paragraphs. Once a segment has been identified, potentially relevant cases are discovered using 2 fundamental approaches: search-based discovery and citation-based discovery. In search-based discovery, we perform full-text searches using the paragraphs within the segment against 2 types of document collections. The first is just an index of case opinions themselves, of which there are about 12 million in total. And the second is a collection of what are called case reference texts, the basic idea here is that a case is represented by all the past instances in which the case is cited. And so the document for a case contains all the preceding contexts in which a citation to that case is made. And that's illustrated in the example on the right. So, and this gives a contextual representation to the case in terms of how it's been interpreted in the past. The second fundamental approach to relevant case discovery leverages the existing citations within an issue segment. These citations, which we call input citations, give a valuable characterization of the legal issue being discussed. And the system adopts 4 different strategies to search for relevant cases. The first approach collects cases that are bibliographically coupled, that is, cases that are citing the same set of cases. And in addition, we look at the collection of past filed briefs and consider all the issue segments from that universe of briefs that have an overlap in citations with the input citations. The second approach leverages a collection of editorial summaries of important cases that have interpreted a statute or regulation. And these annotations have been manually categorized into topics related to the statute, and the candidate cases are those that appear within the same topic as an input citation. The third approach, called pinpoint headnotes, leverages another collection of editorial summaries, headnotes, which are summaries of important points of law in a case. The basic idea in this approach is to identify or pinpoint for which point of law a case in the segment is being cited, and then furthermore to find cases that have cited that same case for the same reason. And then finally, the last approach makes use of user session activity data, such as viewing a case or saving it to a folder on the Westlaw service platform to obtain implicit relevance feedback of cases. And essentially, the candidate cases would be those that commonly appear within the same user session. So the pool of candidates from the discovery stage is passed through 2 ranking SVM models and 1 final ensemble-based classifier, which is a gradient boosted machine. And the first SVM ranker acts primarily as a filter to reduce the candidate pool size down to several hundred cases. And it uses features corresponding to statistics of each discovery pathway. For example, how often a case was found among the top results in full text searches. The second SVM ranker computes additional features measuring the textual and topical similarity of the issue segment and the candidate case. And then finally, the GBM classifier uses features from the first search discovery stage. And this model is mostly used as a means to filter out low confidence recommendations prior to surfacing to the user. So this screenshot here shows one of the system's output recommendations for a particular segment in an uploaded brief. The segment header is highlighted here at the top. Each recommendation is accompanied with additional information that helps to put the case in context for the user, such as such as the input citation text, the input citations that are most relevant to the case recommendation, and the part of the case that is most similar to the issue segment itself. So the performance of our system here was measured against a test set of about 500 briefs corresponding to 2,000 issue segments that cover a variety of jurisdictions and practice areas and motion types. We're reporting here the metrics at 3 levels of granularity. At a recommendation level, the percentage of recommendations that were considered highly relevant, and irrelevant were 39%, 60.5%, and 0.5% respectively. At an issue segment level, the percentage of segments with at least 1 highly relevant recommendation was 67%, and with at least 1 relevant or highly relevant recommendation was 97%. And then finally, at a brief level, the percentage of briefs where at least 1/3 of recommendations were highly relevant was found to be just over 50%. So to summarize, we presented QuickCheck, a system that recommends cases with similar legal issues and facts given a user's input brief document. Importantly, QuickCheck relies on an extensive body of editorial annotations and assets, and this includes both the training set of graded case recommendations collected specifically for this system, as well as existing assets such as case summaries, a comprehensive legal taxonomy system, and a proprietary search engine tuned for the legal domain. Our system has been measured to be robust against a wide variety of brief formatting styles and has been found to be effective across jurisdictions, practice areas, and motion types. Okay, and that's the end of my talk. Thank you.
Thank you very much for the great presentation. Does anyone have, if anyone has questions, can they unmute and ask?
I have a quick one.
Go ahead, Nikos.
My question is why you used three different classifiers, one after the other in a sequential manner. Did you try something simpler, just use one classifier and see how it performs?
Yeah, in fact, it's a good question. The first SVM ranker itself alone, from our sort of initial studies, does actually the bulk of the work. The reason we have three is because the first SVM ranker is, from a performance standpoint, much faster to run, and so we can kind of filter out as many as we can before using a more sophisticated sort of text features. But in the end, it is sort of what we've seen is that the first ranker alone, if you just use that, seems to do a lot of the work, actually. Yeah.
Cool, thanks.
Thanks, great to know. Are there any other questions? Do we have time for a quick one?
There is one
question.
on chat.
Yeah.
Alexandra, do you mind unmuting, or otherwise I can ask as well? Oh, I can ask.
Whether she can't. Okay.
So her question is, do you take the procedural stance of a recommendation into account? So if a recommendation agrees with the argument made or not?
Yeah, so the relevancy scale as defined in this particular system is primarily based on sort of the legal issues and the facts that are being discussed within the case and the segment. Obviously, attorneys will use a case on many other factors, including the posture of the case, the jurisdiction, etc. But for the purposes of the relevancy here, it's primarily sort of text-based in terms of the issue and the facts. Yeah.
Okay, thank you. And thanks again for the presentation. If there are any other questions, you can continue asking in the chat. So our final paper of the workshop is named Explaining Potentially Unfair Clauses to the Consumer Using the CLAUDETTE tool. This paper is authored by a group of researchers from Maastricht University, University of Modena, University of Bologna and BUC, and will be presented by Rūta Liepina from Maastricht University.
Okay, hello everyone. Can you hear me? Can you see the slides?
Yes, we can.
Yeah, great. Okay, so final session of today. My name is Rūta and I'm representing today CLAUDETTE team. As we were introduced, it's multi-university collaboration that started at the European University Institute in 2017. So the main focus of the project is empowering consumers and consumer protection organizations through the use of AI. So far in the project, the main focus has been on detection of unfair clauses in online consumer contracts, but now we'd like to add new feature of providing explanations as to why these detected features are unfair. So if a user wanted to check their online contract, they could enter our website and enter a paragraph and see the detected unfairness clauses. that are based on the current EU framework of Unfair Terms Directive and its annexes. So the previous work, we created a data set of hundreds terms of service documents that were double tagged by legal annotators. So we had legal experts focusing on 9 different unfairness categories, and they were double annotated, and that was a long and quite complicated process due to the different language used by the different companies, and as they also operate globally since GDPR, both the privacy policies and terms of service were updated, creating some more issues. So adding to the previous study, we have now started using the memory networks, and for that we had to create a knowledge base. So for the knowledge base, we chose only 5 categories. So out of the 9, we chose limitation of liability, unilateral change, unilateral termination, content removal, and arbitration. So for these, we gathered 79 different types of explanations, and each of the explanations were based on 300 to 400 different clauses in the data set. So a single clause in a contract can be annotated under different unfairness categories, and they can also be explained by different legal rationales. Okay, as for the method used, and here my colleague Federico Ruggeri would also help me with more technical details later. So for the method used, one possible way for enhancing these explanations can be done through memory augmented neural networks. So for this, in the schema, you can see that we take the input clause as a query. So by accepting these terms of service, you agree to be bound by this arbitration clause and class action waiver. So every input clause is firstly compared with the memory network block through a similarity metric. And this process allows for the relevant content to be extracted from the memory and coupled with the query. So the system uses this information to produce a prediction through a dedicated answer module, and it displays the detected unfairness categories at sentence level and adds the potentially legal rationales related to the unfair terms. So the annotation was at the sentence level, but we also try to include range tags because the context is very important in these documents. So through this process, the memory network not only provides the explanations to the users, but it also further trains the classifier we have for improving detection tasks. So now we could achieve higher accuracy rates for the clauses. So the future work, we'd like to experiment with different types of memory functions and different cycles of iteration. And we'd also like to have more legal analysis of the different market sectors and sort of what sort of patterns emerge, whether similar unfairness categories appear more in, let's say, social networks or travel agency websites. So I think it's a great project both in terms of NLP and legal analysis. So here is a screenshot of our demo tool, and I'll also include the link in the next slide if you want to test it out. So as a user, you enter a sentence or a paragraph. For now, we can take up to 20, 30 sentences for the system to produce the results within 1 or 2 minutes. But of course, we'd like to improve the level such that we can include the entire contract. So as you can see, you enter the sentence, and it in the first iteration, it detects what unfairness category it falls under. So here you can see it's under unilateral termination and content removal. And then below that, you can also now see the legal rationales provided. And here, each of the rationales is paired with the confidence interval. So you can see the first 2 are more relevant and the third is a little bit less relevant. Apologies. Yeah. So we'd like to extend this methodology also to the privacy policies. So the first part of the project mostly focused on terms of services, and now we've increased the data set of the tagged privacy policies. So that's one extension. We'd also like to optimize the tool to be used by different user bases. So we have the consumers, but also the consumer protection agencies and NGOs in Europe and beyond. And that's it for the short presentation. You can contact us on the website and also check out the tool there. Thank you.
Thank you very much. If anyone has any questions, for a couple, yourself and ask. I had a very short, very quick question. What was the inter? You said in the beginning that multiple annotators annotated. What is the inter-annotator agreement? Do you have any measure of that? Is that a very challenging task? Or?
Yeah, it's a challenge that I don't have the numbers on hand because we also had several iterations when we changed the guidelines. Because we're using the Unfair Terms Directive as the basis, and because we had legal annotators, firstly, the agreement was quite large. This agreement was quite large, but then in the second and third level, it was reduced. Federico, maybe you have the figures in hand. If not, they might be in the paper.
I was just curious if it is relatively a task where people usually agree, or is it challenging?
So I would say for terms of service, it was easier. For privacy policies, it's where we struggle more because the language is more varied on how companies decide to explain their terms. So there, we definitely saw a difference between terms of service and privacy policies.
Yeah, it would be very interesting to have just an analysis of what kind of throws people off in the wording. Okay, cool. Are there any other questions?
I have a quick one, if nobody else wants to. Rūta, thanks. It was a very interesting talk. My question is about the latency of your model, and given that contracts usually might be very long, have you tried any more lightweight models under the hood? Because you said you use this memory network that might be quite data hungry and large in terms of parameters. Have you tried any less sophisticated machine learning algorithm for your system to see if that actually works?
Yeah, here I'll let Federico answer because I know the team of computer scientists had compared several ones, but I don't know which ones exactly.
Yeah, I think I can answer. You can hear me well?
Yep.
Okay, so we tried some basic models, some baselines also in the paper that is currently under submission, like recurrent networks or just feed-forward networks. The main issue is that it's not so easy to integrate the rationales into the architecture. And from the point of view of greediness, the main issue is when the memory becomes very big. So if you consider a very large set of rationals, there has been some work on some ways to approximate the memory lookup operation. So the similarity operation with the close to classify and the set of legal rationals. And in the context of this type of architecture, and also there are also more recent works that aim to use the network directly as a simple multilayer perceptron to read and write operations. So you don't have a cell for each input, but you just give an input to another neural network that is taught to reconstruct the output. So you don't have these explosions in terms of space when you try to consider a large set of rationals. This, of course, is one of the future research we aim to investigate, but right now we have a a very limited amount of rationales. So we are mainly focused on investigating whether this is the right approach, or to analyze the issues about considering raw text.
Thanks, Federico.
You're welcome.
Thank you. And if there's no other questions, I would like to thank Rūta again for the great presentation. And everyone, this concludes the paper presentations for the whole workshop. So thank you everyone again for attending and staying a bit over the original schedule we prepared. And thanks again for all the speakers from today. I know how challenging it is to present remotely, and everyone has made a great effort to make this workshop a success. So thank you everyone. And with this, I also wanted again to review how you can view more information about the workshop for those that missed the start of it. So I'm going to share my screen real quickly. Okay, so all the pre-recording videos will be, for the archival papers, are in VFairs. Right now, I think we're missing 3 due to a technical issue on the KDD side, but we have it promised that this will be solved today. So this will be available throughout the conference and 30 days after the conference. The videos themselves are on Vimeo, actually. So we have linked the original Vimeo recording from the workshop website from nlpw.org. We have a YouTube channel, which we were planning to stream initially, but we couldn't manage to get all the permissions in time. So we've recorded all the presentations and we'll try to make as many as possible, including the keynote, available there. And for the papers, you can view directly the proceedings at CRWS, and they are also available from the workshop website.